Hi all, welcome to the Riot Lunch and Learn series, the place where we spotlight Riot's sponsors and partners. My name is Natalie Ballard. I'm the Events and Operations Manager for Riot. Just a couple quick reminders before we get started. This event is being recorded and will be posted to Riot's YouTube channel and uploaded to the meetup page where you registered for this event. If you have any questions throughout the presentation, please place them in the chat. I'll be monitoring the chat and will read the questions aloud throughout the presentation. Questions are read aloud for those watching the presentation at a later date. Finally, please keep yourself muted throughout the event to help mitigate background noise. Today, we have TJ Van Tol from Blues Wireless to discuss building custom GPS trackers from scratch. TJ, I'll turn it over to you.
Thank you. I'm going to go ahead and bring up my screen and let's talk GPS. So my name is TJ Van Tol. I work for a company called Blues. I'll talk a little bit more about myself and what we do at Blues here throughout this talk, but I kind of want to just dive right in and start talking about GPS. And specifically what I want to do today is start by giving a little background of how GPS works, how GPS receivers work. Even if you have some background or some thoughts of that, I'm trying to include some just random facts or some interesting material that can set the stage for the second part of this talk, where we're going to actually build our own tracker. So I have two different ones that I'm going to be building. One I'm going to actually sort of try out here and deploy live and show you how you can build it yourself with Blues hardware. And then for the second part, I'm going to just refer you to a project that I built that kind of got me into this topic in the first place. And that project's totally open source and available, and I'll link you off to that if you want to learn more. If you do have any questions, feel free to drop those in the QA, and we'll do our best to answer those throughout the talk and then also circle back to those at the end. But yeah, let's talk GPS and how GPS works. And the story of GPS really starts with this satellite you may or may not recognize. This is actually Sputnik. So the Russians sent up in 1957. And the reason this is the start of GPS is because this satellite set up by the Russians emitted a radio frequency. And the Russians purposefully did this because they literally wanted to broadcast to the world that they had started the space race, that they had put the first satellite into orbit. What scientists, though, soon discovered is that by measuring the radio waves and the time, essentially the Doppler shift from the time it took that signal to get down to Earth, they could actually determine Sputnik's location up in space. And they also figured out that you could reverse the process. That is, if you had multiple satellites up in space, you could use that, basically the position and the signal from there, to determine the position of a receiver down on Earth. So the US started deploying satellites. This is what's called the Navy Transit 1B. It was launched in April of 1960 from Cape Canaveral. It was about this big. I just found this picture amusing because I have absolutely no idea what the guy in the background is. It kind of looks like he has a stethoscope. But basically, the US spent the 60s and the 70s deploying these things up to space. I found an old picture of the first one of these heading up in a rocket from Cape Canaveral. And actually, by 1968, the US had a fully operational system of satellites, 36 of them up in space. So we had the ability to basically geolocate things a lot earlier than a lot of people realize. And early applications of this were basically all the military. The military wanted to drop a missile. They wanted to drop the missile very precisely. And the satellites were mostly used with that intention very early on. As time went by, the tech in the actual satellites got more advanced. There was this thing, which looks kind of comical, but it is the atomic clock. Essentially, an atomic clock can take accurate measurements to within 1 in 15 billionth of a second per year. So incredibly accurate time. And accurate time matters a lot for GPS because essentially what we're measuring is the time it takes a signal to go from space down to something on the ground. And so since you're measuring that time, having the time very precisely is kind of important. So we started putting smaller versions of these atomic clocks in the satellites we were sending up in 1974. And having more accurate time allowed us to build smaller receivers. So I thought this thing was amusing. This was the Magellan Nav 1000, which you could buy as a just regular person in 1988. You could buy it if you had $3,000 in 1988 money, though. So it was still a little out of the realm of the average person to carry around, but it was kind of interesting in the sense that it was one of the first GPS things that you could buy just as a person and actually carry around with you. The thing that made GPS something that all of us here use on a daily basis and all of us know about are due to two governmental changes that were made. The first was done in 1983. The Reagan administration were the first that opened up GPS for non-military, not governmental use. So that's what allowed those personal devices to be created. It's what allowed pilots to be able to start using GPS as well. But the GPS program at first was made available under what's called selective availability. Essentially, the government just fuzzed the numbers from GPS because they were worried about the tech falling into the wrong hands. So GPS was available, but was kind of purposefully made inaccurate. And that program remained in place for 17 years. And it wasn't until the Clinton administration that that was taken down and GPS became available, accurate GPS became available for just random people to be used. And that is why, if you're old enough to have driven in the early 2000s, you probably remember these things, because the early 2000s is when we started to get actual GPS devices that were at a price point and an accuracy level that people could use to navigate and whatnot, and was started basically the birth of modern GPS that led into the types of devices that we're going to be talking about today. Just as a fun, other couple fun pictures I look like, in case you were curious, this is what a modern GPS satellite looks like. So when we're actually getting data from space, this is the thing that is sending those signals down to Earth. Those big things on the side are solar paneled. These satellites are solar powered, although they have a massive battery on board as a backup as well. There are 31 of these satellites in orbit right now, and this is what they look like on the ground. They are kind of large, so we have to send some pretty big, use some pretty big rockets to get them up into orbit. And just as a bit of nomenclature, the term GPS refers to the US government program and the US global satellite system, but there are actually several different satellite systems that are used worldwide. There's GLONASS in Russia, China, EU, India. Some other countries have their own systems of satellites as well. And most modern receivers, the things that we're going to be using to actually get GPS coordinates, are technically GNSS receivers, because essentially, if you're building a system that determines location, the more satellites you can see, the better. So they're going to look for any satellite up there and any data they can get to help target and pinpoint a location down on Earth. So we use GPS a lot just because it's a convenient term, but technically a lot of the receivers that we use day in, day out are GNSS receivers. That's basically how GPS works, but that's only part of the story because that's the satellites up in space. I want to talk a little bit about how the actual receivers, how things like our phone actually work, because this is going to play into when we're building our own equipment here in a minute. But I do have one quick aside, just in the same context of sharing fun things that I found on the internet while researching this, because I found this amazing article on nasa.gov with the title, Where Do Old Satellites Go When They Die? Which I think is super interesting because it's a question that I had never thought about, but then was immediately curious about the answer, especially when NASA had this pretty amazing graphic to go with it. And the answer is actually threefold, just in case you were curious as well. Turns out for the teeny tiny satellites, the smallest of them, we basically just let them fall down to Earth. We kind of slow them down. And NASA had this kind of amazing quote: the heat from the friction of the air burns up the satellite as it falls towards Earth at thousands of miles per hour. And ta-da, no more satellites. So today you learned small satellites, we just let them burn up. Medium-sized satellites, we direct to fall in an area of the South Pacific Ocean called the spacecraft cemetery. Essentially, it's just an incredibly remote part of the ocean where if the satellite's small enough that it can fall down to Earth, but big enough that it's not going to totally burn up, we basically direct it to fall there. I also had no idea this existed. And finally, the biggest of satellites, the ones that we just can't send down to Earth because they're too big, we basically just send them as far away from Earth as we can. into a graveyard orbit and kind of just let it sit out there as space junk for a later generation to worry about. So today you learned about all the random things we do with satellites. So there is your fun aside. But I do want to talk about GPS receivers. And another great NASA illustration is this one, is that the GPS system, so those are the satellites. My first little bit was talking about the satellites, how we get them up to space, how they send down signal. There's also ground stations that, and a surprising number of these things. I was kind of blown away by this diagram when I found it on gps.gov, which is another really interesting and useful government website. But we have 20 some of these worldwide, and this is just for the GPS system, so just the US controlled satellites. And essentially these stations they're tasked with making sure that the satellites are doing what they're supposed to do, that they are where they're supposed to be, that their signals remain accurate. They have some ability to change and control things up on the satellites up in space. And so there are a lot of these positioned worldwide. So the ground stations are basically checking on the satellites, making sure everything's good there. The satellites themselves are beaming down signals that can be picked up from Earth from GPS receivers that have some sort of antenna that's tuned for picking up the signals that these satellites are sending down. Now, the specific signal has a few different pieces of information in it. It's going to have identifying information about which satellite is sending it, satellite's position, the current date time, where the satellite's supposed to be, where it has been. A lot of data gets packed into there. So those signals are beaming down to Earth. They do get interfered with, and this is one of the tricky bits when building GPS types of apps. They'll get affected by different layers of the atmosphere. They'll get affected by tall buildings and rocks and walls. This is probably something you've experienced if you've ever tried to navigate with GPS in a large city. If you've ever gotten off of a subway and looked at your phone, and your position is bouncing all around. The reason for that is because the signal coming down from space, it's measuring how long that signal takes to get down to your device. And if that signal is bouncing a bit off of buildings, we have some ability to know that there's been some interference and some dilution as that signal came down, but it does mean the device is far less confident in exactly where the location is, which is why you're bouncing around when you get off of the subway. So the ultimate job of a GPS receiver is to take all of this data, this just sort of raw data that's beaming down all the time, and turn it into what we really care about, which is usually just a latitude and a longitude, maybe an altitude, something like that, but doing the raw math to produce that value. And I went briefly down the path of I'm a reasonably smart person. How hard could that really be to do? And the good news there is that this is a very common problem. It's a well-researched problem. So there are very exhaustive tutorials, documentation on exactly how to calculate these sorts of things. But when it got into the specifics, I laughed when I found this Stack Overflow post because it's discussing it. And then it has this little bit about this last trivial step that you need to do to calculate it. And then it busts out more trigonometry than I care to do or care to research. So if you're like me, you can just feel confident in knowing at least a little bit of a background in how this works, but use something out there that automatically is set up to receive those values coming down and just produce nice human-friendly things for you to use. And you can find a lot of those things out there. So if you just look up GPS receiver on Google or Amazon or whatever, you'll find a wide swath of everything. You'll find Garmin devices that are just modern devices that just show you on a map. You'll find just little chips that you can use and integrate into IoT projects, and some that are just somewhere in between, right? There's lots of different material. There's lots of different ways that you can solve this problem. So what I want to do is help you sift a little bit through that noise and give sort of my opinionated way that you can use some Blues tech to sort of solve this problem and why you can get into this. So when it comes to building your own tracker, which I want to get into next, I want to talk about why you would want to do this in the first place. Because as I mentioned, there's all sorts of tools out there. Why would you build this when there are so many trackers that exist? There's so many things that you can do. My favorite tracker that's just commercially available right now is the AirTag. So we have several of these. A lot of them are in some of our kids' stuff. And basically they're little button-sized pins that you can throw in any sort of, really anything, a bag, a purse, a backpack, attach it to luggage and whatnot. And it'll sort of in the background track an item that you can view from an iPhone or any sort of Apple devices. There are also trackers out there for a whole bunch of other things. So if you have kids, you might know that sometimes you'd like to track them, especially at things like events or parks or whatnot. And there are a number of trackers that are available for that. There are car trackers, there are boat trackers. Those are easy to find and plentifully available. There are dog and cat and animal trackers, although if you have a cat and your cat will actually wear one of these things, you'll have to let me know, but there are trackers out there that you can use. So given that, why would you do this, right? Why build your own tracker? Why even go down this route of tinkering? So one reason is just money, because almost all of these devices not only cost money to just purchase the device itself, but they almost always have some sort of subscription costs associated with them. And the reason for this is that with any sort of tracker, not only does the tracker have to do the job of getting that signal down from space and making sense of it, it's also, to be useful, usually has to beam that information back up to the cloud somewhere so that it can be viewed in a dashboard or so that it can send alerts or notification or whatnot. Otherwise, it's kind of useful. Like a tracker can know where it is, but unless it can tell the outside world where it is, it doesn't provide a whole lot of value. And so for companies to sustainably run these tracker businesses, they have to pass some of that cost back along to their users. So you'll see subscription costs. Those were for some of the kid trackers. Virtually every, if not every, car, vehicle, boat tracker includes some sort of subscription cost as well. Even our friend, the cat tracker, starts at $12 a month because they have to run a sustainable business as well. So you can, by building your own, you can kind of, as you're going to see, reduce some of the cost, not only of the initial purchase, but also the ongoing cost and the being tethered to some sort of external service. The second reason is customizability. So even if you take the AirTag, which is, I think, one of the only examples of a tracker I know of that doesn't have a monthly cost associated with it, although you could argue that like being compelled to continue using Apple products is you're kind of becoming more tethered to that ecosystem. But even with the AirTag, there are some limitations. Like they only work on Apple devices. You cannot buy an AirTag and use it with an Android device or a Windows laptop or anything like that. You also have no ability to view your data outside of Apple devices. So even if you wanted to just give the location or view the location on an Android device, you really have no recourse or no ability to do that. You can't build your own custom dashboard. You can't add any sort of custom functionality, any sort of custom behavior. You have no ability to set up custom notifications or alerts. So if you want to do something like the last on my list, geofencing, if you want to know when your dog left your yard or your kids left the neighborhood or your car left an area that it wasn't, that it was supposed to be in, your car left the garage or the state or whatever, you have no ability to set up those sorts of really custom behaviors. So customizability is the other reason to build your own tracker. And the last that I have on my list is just fun, right? Chances are you were at this lunch and learn because to some degree you enjoy coding or you enjoy firmware or you enjoy hardware. You like to tinker, you like to mess with things. And I can say from my own personal experience that building trackers is just a really fun thing to toy with. At least I've had fun. You can build things that are just useful for your life, just around your day-to-day activities. And potentially you can build things that are also useful from a commercial perspective as well. There's lots of reasons that people need to track all sorts of things. All right, so how do you build your own tracker? Well, there are a lot of options for doing this. This can be a topic that we could spend several days on, but fundamentally at the most extreme high level, there are two problems you need to solve anytime you're tracking anything. So the first is the actual bit about the receiver. Like, how are you actually going to, what antenna are you going to use? How are you going to get that satellite information? How are you going to translate that into an actual set of coordinates that you can use? And the second question is then once you have that data, how do you get that data back up to the cloud? how are you going to then view it in like a dashboard or even just a list or a static position on the map? How are you going to actually do something with that data? And this is where I think where I work at Blues comes in, because we make a product that I believe elegantly solves both of those problems in one elegant package. So we make the note card, which I've got one of here. It's about 30 by 35 millimeters. So hopefully you can get a sense of how big that is compared to my hand. And we make two varieties of the note card that you see on the slide. One is cellular here, and then this is a Wi-Fi one. I'm going to be focusing only on the cellular one today. And the reason why I think it's a really, really elegant solution for this situation is that it is both a cellular product. So there's a cellular modem on the back of this note card. And it also has a GPS receiver baked into it as well. So it's just kind of one package that elegantly solves both problems related to tracking. The cellular bit too has what I think is a really compelling just offering or just cost structure. When you buy a note card, you get 500 megs of cell data included with the price of the note card and 10 years of service as well. The note card's API is JSON based, so you don't interact with the modem directly with a note card. Instead, we abstract everything into a set of JSON commands for working with data and for working with tracking as well. You can use the note card on its own, and we also provide SDKs for a variety of different languages. So Python, Go, CircuitPython, Arduino, Zephyr, C, C++, a number of different languages as well. So if you're building something more advanced, you need a bit of firmware to control the note card and to work with it. You can do that pretty elegantly with the note card as well. Now, I'm going to show you how this works, but I'm going to give you two more terms here real quick that are going to help you understand what I'm building a little bit more. The next is the note carrier, which is also something that we make at Blues. The note carrier is really just a set of development boards that make prototyping with the note card easy. So the note card has this, I can go back to show it on the slides. It has this M2 edge connector. This is designed to make it easy to embed into any sort of IoT projects. But if you're like me and you're not the most hardware aware type of person, we know a lot of people just want something easy to plug it into and get started with. And that's really what the note carriers are about. We make a variety of these things. I'm going to be using one today for at least my first demo called the Note Carrier B, which the B stands for basic, partially because it is very tiny. And really all I'm using the Note Carrier B for is I've got two things plugged into it. I've got a LiPo battery here. The battery is going to be charging this device because one thing about trackers, usually they have to be battery or solar powered, because in a minute I'm going to take this off and send this out so we can actually get some coordinates. And the other thing is I'm using it to provide a USB connection as well. So I've got this plugged into my computer because in a minute, I'm going to show you how to send commands to the note card to actually configure it as an asset tracker. But that's basically it. There's just one package here with the note card and the note carrier, and that's really all the hardware I need to have a fully functional asset tracker. The last piece of the puzzle is NoteHub. So one cool thing about the note card, I said it had a solution that you could use cellular to get your GPS data. NoteHub is where the note card sends its data to. It is basically the note card's secure cloud service that it communicates with and sort of works as a partner with. You can get your data up into NoteHub, and then you can route it out to any other cloud app you want to use. So if you want to get your tracking data and send it to your own HTTP endpoint, you can send it to your AWS, your GCP, Azure, whatever. You can route it to a dashboarding service if all you care about is, I just want to see this thing on a map. There are easy ways of enabling that as well. So you have a lot of options. There are other things you can do if you're starting to scale out, build larger fleet management, some firmware updates. There's lots of things you can do in there as well. But for today's purposes, NoteHub is basically the place, the cloud service that's going to get our tracking data and let us do something interesting with it. All right, so I want to show a demo because I think a lot of this is easier to understand if you just see it in action. So what I'm going to do is bring over my monitor. And I should mention too, that just to give you an idea, because I didn't have any prices on that slide or anything, everything I'm showing today is something that you can build using a Blues starter kit, which you can find on shop.blues.io. Starts at $100. I'm going to have a discount code on my last slide as well to bring the price down of that a little more. So if you do want to build any of this, the starter kit can help you build both of the two projects that I'm showing today. So the starter kit, and once you have a starter kit, the place to get started with, and what I'm going to be showing this off, is using dev.blues.io, which is our documentation hub for all things blues. Now, what I'm going to do is head into the quick start, because that's where we recommend starting with a note card, and head to the note card and note carrier quick start. Now, what you can do from this quick start, well, first of all, this quick start is what I'd recommend going through if you're just learning to look how the note card works, what it does, how to set it up and everything. It's going to talk you through like how to actually connect everything that you get in the box and whatnot and how to set everything up. And it's also going to show you how to use this section of the docs. So this is actually, to me, one of the coolest things that we let you do. We actually let you perform a serial connection over USB to the note card directly in your web browser. Meaning you can essentially start talking to your note card and sending requests right here. You don't have to get into more complicated firmware or whatnot. You don't have to do craziness. You can just start working right here. And there are actually only 3 commands that you need to set up the note card as an asset tracker. I'm just bringing up my notes to grab them here. The first one, and keep in mind the note card's APIs are all JSON, so I'm not sending anything super complex to the note card. I'm just sending JSON commands. So the first command I need to set is one called hub.set. This is what associates the note card. So I have a note card sitting on my desk, but again, my note card needs to know where to send its data to, which is NoteHub, but it needs to know what project to send it to. So in NoteHub, I have the ability to create projects, which are just ways of grouping devices and the data that you have coming from your note card. I created one for today called Riot. So that's where we're at. So at the moment, I'm just going to copy that identifier because that's really all I need. I'm just going to associate this note card with that NoteHub backend with that identifier. I'm going to set a, oops, I got to grab I hit the wrong button. So I guess going to have to go back and copy this identifier again, which is here. Again, this is just making the connection between the device that I have on my desk and the cloud backend where I'm going to send this. I'm also providing a mode. The note card can work in what we call periodic or continuous mode. Continuous mode maintains a continuous cellular connection using the cellular modem, which can be useful in some scenarios, but for asset tracking use cases, you almost always want to be in periodic mode, just because usually you're running off of some sort of battery, and maintaining that constant connection is a great way of depleting that battery fairly quickly, but you can customize it based off your situation and what you're building. And then you also have to provide an outbound interval. So this is how often the note card should take data and send it up to the cloud, send it up to NoteHub. This is, again, something that what you're going to want to use here is going to depend wildly based off whatever it is you're building. I'm setting this to a low value because I'm going to try to demo this a little bit. And so I'm going to say every 5 minutes, send things up. That's pretty darn frequent. You probably wouldn't want that for sort of a production tracker, but for a demo, it works just fine. So I'm going to do that. I'm going to sync this up real quick as well. Syncing is just saying, taking any data I've accumulated on a note card, like my set, and pushing that up so that it is available up in NoteHub. The second command that I need to run is one called card.location.mode. So this is, again, a bit of configuration. This time the configuration is for the actual GPS module. The mode is, again, continuous versus periodic. And again, it's something you're probably almost always going to want to set to periodic for asset tracking use cases, just because unless you're in the rare situation where you have constant power and you also need to constantly know where an asset is at, usually you just want to take periodic readings. So in this case, card.location.mode is how often to take readings, how often the GPS module should figure out where the person is at. So I've set this to 60 seconds because I'm going to try to demo this. This is, again, fairly aggressive. This is demo settings because I just want to get readings constant so you can see a little bit of how this works. So card.location.mode, I'm going to do that as well. And finally, the last command is the easiest of them, card.location.track and start true. That basically just says to start the asset tracking. So at this point with these 3 commands, and I'll say again, like all commands that I'm able to run through JSON, if I head up here, this is all I need to do. This note card, when I got it, was I basically just factory reset this note card. So this is something you could totally get from our starter kit, unbox, run these 3 commands. And I've got a device that's now going to take readings, GPS readings every minute, and then every 5 minutes, sync those readings up to NoteHub. And it's really started tracking right away. So what I'm going to do is, as you might imagine, GPS is really, really difficult to demo in this sort of talk, because I can't exactly just get in my car and go drive around or anything. So what I'm going to do is I just unplugged this device from my computer that I just set up. I'm going to put it in a little baggie, and my wife has kindly volunteered to help me out. We normally go for a walk together this time of day anyways, so she's going on the walk without me, and she's going to take this thing with me. So I'm just going to go quickly hand this to her. If you have any questions, this is a nice logical just pause point in the talk. So if you have any questions, I'm going to be on for like 10 seconds. Toss them in the chat, and then I'm going to check the QA when I'm back. All right, I am back. So she's heading out for a walk. I'm going to check the Q&A real quick. Do we have any questions? I'm not seeing anything at the moment. What other type of data can be set from Mike? So technically just about anything. So the way I configured the note card was just to send out the location. But if you head through this quick start, you'll see some of the other things that you can do. For example, I could hook up just about any sensor you can imagine and just arbitrarily push that data up as well. So one thing we have a lot of our users do is they're doing GPS tracking alongside something else. Like say, I need to track where a piece of equipment is, but I also need to track its gas level or oil level or condition. You can use the note card to do that. I have refrigerators that I need to know where they're at because they get moved around the country or whatnot, but I also need to know their temperature, and I need to know when the temperature goes above this because that means something is bad and I need to know about it. The note card works really well for doing that sort of thing as well. Can an MCU send data as well? Yes, and actually that's a great segue because the next example I'm going to show is going to do exactly that. And then Andrew's asking a question. Why'd you all decide to use JSON for your API? And I think it's because it's one format that's pretty commonly available across sort of programming ecosystems. And I'll say that it is much better than if you ever had to work with a cellular modem directly, you would take literally anything over that, any XML, YAML, whatever. You don't want to touch the AT commands directly. So our ultimate goal was to put a facade over that was easier to use. And JSON, I've enjoyed using it. It's just a common format. It's really simple too. I think the rules of JSON are really straightforward, which helps use those as well. Pierce, is there good information on there in general, maybe very general estimates of battery life based off logging and transmitting frequency? So Pierce, this is what the main thing I struggle with as well. I feel like I almost, I'm still relatively new to the IoT side of things, especially like the electrical sides, and I struggle with this as well. I'll say that like maybe somebody else can help in the chat too, because I struggle, but the LiPo batteries I have tend to last a couple of days. It's kind of one of those things that you have to try. The one cool thing is that the note card will automatically report voltage levels up. So one thing you can do is try things out and just measure how long batteries are lasting. You can basically see a graph of your voltage over time. I think I might have it in here. So the thing that's helped me the most, here's voltage, which this chart, is it this one voltage? That's signal strength, this one's voltage. This thing was plugged into my computer, so that's why it's giving me straight 5 volts. But if this were a more realistic app and I sent this out in the field, this is the most helpful thing to me, is I just monitor my voltage over time. and then I use that to adjust. Basically, I just put in real world settings, see what happens, and then adjust from there. That's kind of my best advice. All right, so my wife is heading out for a walk, and what's going to happen now, I set up this note card, I set up this configuration. It was set to this Note Hub project. And what's going to happen is I'm going to start seeing events coming in to the back end here. And actually, I already did get one here that probably got from my desk right before I left. You can also see some of the events. I tested this out on a little walk earlier this morning. But essentially, I'm going to get data in this format, this track.qo format. And if I go in here, you'll see in JSON here, down here, I'm getting various information. Like this is the main thing we care about, right? Latitude and longitude coming through. And then this is data that I could then use to put on a map or do whatever I would like to do. So I'm going to show you a demo of what to do with this data out of Note Hub, because as you might imagine, even though you can get the data, seeing it in this like HTML table isn't super interesting. But I'm going to wait a minute to see if this tracker is going to work, which is questionable. If not, I'll just show up with some of this old data. But I want to use some new data to show that off. In the meantime, I want to show one additional project. And the question about using it with a host was actually quite interesting, because that's the next thing that I want to discuss. And it's building a tracker where you actually want to utilize some code. So my first tracker was simple. It was something you could buy a kit from our store. You can run some JSON to configure it. I should also show too, in addition to what I showed for configuration, the best place to go is in our guides and tutorial, and we have an asset tracking article. And I'll actually quickly just drop this in the chat too, so other people can check this out. This walks through everything I showed, but in like way more detail. So all the commands I wrote, I did in some others on how you can configure things. So if you want to dive into this later, that's the best place to go for that. But sometimes with a tracker, you need to go beyond just setting a few configuration values. Sometimes, as one of the questions alluded to, you have some other data that you're working with. You need to also grab a temperature from a sensor and send that along with your coordinates. Sometimes you have a little bit of additional functionality you need. And for that, you need some ability to write some sort of code on some sort of host or microcontroller and run that alongside the note card. And to give you one example, I'm going to tell you a quick story of the project that I built and what kind of got me into this topic into the first place. So I have twin now 12-year-old kids that are getting bigger every day, and they like to ride their bikes. And they like to ride their bikes on a trail system that we have here in Lansing that we're pretty proud of, that's got miles and miles of trails around the river. And my use case was, hey, my kids are doing this and they're now way more capable athletically than I am. So I want to give them the ability to explore and be very independent. But me as a paranoid parent, I also wanted to keep tabs on them. And more importantly, I needed the bit of extra functionality I wanted them to have some ability to press a button and basically treat that button as like the SOS button or the help me button, so that they'd have something that if they got a flat tire or something went wrong and they needed to reach out, they'd have some way of doing that. They don't have smartphones or anything, so they needed something that could track them and give them some sort of phone home access to send me a message. Now, to do that, I immediately needed some sort of code, because the note card itself was not just a general processing computer. It's a system on module. It's designed for interacting with cellular data, GPS data, and not just a general purpose computing device. So for that, I need some sort of microcontroller. So something, if you're not from the IoT space, basically just something that can run code, some small thing that can run code and run it on a limited supply of power. Now, there are a lot of microcontrollers out there. We designed the note card to work with essentially any of them. We are very microcontroller, single board computer agnostic. We don't really care what you use. So if you have experience in this space and you have tooling and an ecosystem you like using, check out our docs. We have lots of information on how you can integrate with the note card. But if you are the sort of person that's not familiar with the space, or you just want the happy or the easy path, our starter kit does include a microcontroller we call the Swan. It's a microcontroller that has an STM32 based chip. It has this Feather compatible dev board, which Feather, if you've not heard that term before, is just the pattern of the headers of these things so that it can slot into a variety of compatible devices. It's got plenty of processing power. It's plenty beefy enough to handle tracking. And it also supports C, C++, Arduino, Zephyr, CircuitPython, and others. And the cool thing is, so when fully assembled, our starter kit, if you check out my camera for a second, looks a little something like this, where I've got one of our note carriers, and you can see the Swan slots into it and the note card as well. So you get one kind of complete package that I think is really elegant, and which allows you to use the note card and to use the note card along with a microcontroller, and in a way that everything's just kind of wired up for you. So if you're bad at that sort of thing, like I am, you just have one really nice, elegant package that lets you kind of take advantage of the microcontroller and the note card. And again, you can interact with the Swan and with the note card because we have SDKs for the note card that are available in a wide variety of languages. So I'm going to show you quickly. I'm not going to walk through the entirety of that project. I am going to real quick put my complete write-up for this into the chat. So if you do want to go into detail, the full source code for this is in here as well. Somewhere in here, code. Somewhere in here, there's a full GitHub link so you can check out the full code. I do want to give you sort of like the bird's eye view of what this thing is actually doing, and hopefully convince you that even though this looks fairly intimidating at first, especially if you're new to this space, that what I'm doing is actually not all that hard. So this is Arduino. This is the Arduino IDE. This is the sort of standard IDE for working with Arduino-based microcontrollers, which the Swan supports Arduino. It looks like there's a lot going on, but like I said, a lot of this is fairly like stuff I copied and pasted, quite frankly. So first of all, I'll point out that this big chunk, you'll recognize these as the 3 commands that I ran in my web browser. So hub.set, card.location.mode, card.location.track. So that same config necessary for configuring this as an asset tracker. I'm just doing this now in my firmware instead of basically manually typing those in through a web browser. In my loop later down, I'm doing this bit where I want to know if my kids pressed a button. So when the button's pressed, I've got this somewhere here. I've got this generic Arduino code I found for working with a button. It says, hey, when they press this button, flip this flag, this location requested flag to true. And then in my loop down here, and again, sorry if you're not following along with everything, I've got the link in chat, but if they have requested a location, I've got this chunk of code that's actually going to get the current location and do something with it. But this chunk of code is something that I quite literally copied and pasted from our docs. So there's this section here on taking an immediate reading. Essentially, anytime you want your tracker to take an immediate reading of where it is right now for sort of like SOS types of scenarios, there's some code down here. I think this is what I copied and pasted quite literally down here to actually do that. And then the only other thing this project does is once it gets that location, it uses another note card command to actually send that location out. So in this case, it's not going through that track QO system that I showed earlier. In this case, I need to push a very specific, basically a message out that my kids are requesting me. I'm using another of the note cards requests called note.add to push that out. And I'm using Twilio so that I actually get an alert, a notification on my device. So that in practice, if I bring my slides back up, what I ended up doing is I took this build and I put it in one of these under seat carriers, which these things are actually quite handy. I did have to buy a few of them because some of them bounced around too bit and wouldn't stick to the bottom of the bike seat. But I found a pretty good one. These things are handy also for just carrying like phones or wallets or keys or whatnot as well. But I tossed my tracker in there and I sent my kids out, and it took a couple of tries to get the configuration right and to get everything situated. But what I ended up with was a tracker where I had a dashboard where I could see kind of where they were at. I think I had it sending up like every 5 minutes. In my case, I didn't have to worry too much about battery because essentially I could charge the battery in between every use. So I kind of erred on the side of pushing things up fairly frequently. And then I gave them a button where they could press it and then send me a text message. And we discovered a kind of accidental use case of this is that it was a surprisingly fun hide and seek sort of device to see how accurate this was, because they could press the button and kind of hide somewhere and see if I could find them. So we had some fun just messing around with that. And that's kind of what I'm getting at it, where it's just like the fun aspect. It's you can have a lot of fun with this sort of tech. So again, I walk all through this in this Hackster write-up. If you do want to learn more, because I tell the full story of how I built it and some more detail about the code and how all of that works. So the last bit I want to cover, actually, I'll check for, I don't see any more questions in the chat. So if you do have any questions, feel free to type those in. But in the meantime, what I want to show is this event. So hopefully we'll refresh this, and I'm not seeing any events. So I think something must have went wrong with my tracker because I'm not seeing any new events come in, but that's all right. We can still show off with what we've got. So this one track QO came in right as I set this up. So this is the absolute location of my desk. The last Note Hub feature I want to show is how to take this data and basically get it out of Note Hub and somewhere where you find it useful. We provide this functionality through what we call routes. So routes are ways that you can take your data, and as it comes into Note Hub can sort of conditionally or however you'd like, send your data off to some other sort of endpoint, whether that is just HTTP or, again, one of the big clouds. There's Twilio, which is how I ended up doing, or one of the things I ended up doing for my kid tracker. Now, we have tutorials on all of this. So in our docs, I'll drop this link into the chat. As well, we have docs that walk through a number of different ways that you can do this and send your data out. The tutorial, or the approach I ended up using for this, is a solution called DataCake, which is a dashboard provider that we like using here at Blues. It's also really great for tinkerers because they give you 2 devices that you can use for free. So if you're just sort of trying out one of these projects and you want to just have a map to see your GPS data, it's really easy to do that. You can do it for totally free. It's really easy to use. And if you follow this tutorial, it'll have you set up a dashboard and then add it as a route. So you'll see for DataCake here, I have a route set up with the dashboard I created. I've got that dashboard over here. And you can see I think I did get at least one coordinate from her moving a little while ago. And I set up this dashboard. You can configure any of this. Like I'm also gathering, because the note card publishes things like its voltage, its signal. The note card has an onboard temperature reading, so it's pushing that up as well. You can build graphs over time. And then this chart here, this chart is only going to have my current location at my desk, because it still hasn't, I think it's picked up the start of a walk, but nothing more. I'm not sure if I configured something wrong or whatnot, but this is basically the flow of how things work when you're using the note card. To take a step back, the full picture, really you configure your note card either in the browser by sending commands, or you go a little more fully featured and you write some firmware for working with the note card and doing whatever else your project needs. You push that out, you send it into the field, that data starts flowing into Note Hub automatically. So you have data coming in at a regular interval, and then you can take that data and route it wherever you want it to go. So your own custom server, your own cloud, some third-party dashboard or whatever. And then essentially you have something that can, did it just pick that up? Now I'm seeing 17 minutes ago in the dashboard. But you have the data wherever you need it and wherever you want to push it out. So that's the total flow. Hopefully you find that approach kind of interesting. I'm certainly fascinated by it. I hope you can tell I've built some interesting things and have a lot of fun tinkering with this. And those are some ideas of the sort of thing you can build. If you're looking for additional sources of inspiration, some other ideas for what you can build, if you just Google Hackster Blues Wireless, you can find some of the many projects that we've built with a note card. Some of them are really interesting. So you see my kid tracker is available there. One of my coworkers, Rob Lauer, quite literally sent a note card around the world and did a write-up of the process around there and some of the things he found from doing that. That's really cool as well. So if you look there, we've got like 75 projects up there, and a good handful of them are related to asset tracking. So that's a good resource to check out. And then, yeah, last few things to mention. If you do find any of this interesting, blues.dev is the best place to go. So that is our documentation site. That's where you're going to find a lot of these resources related to using the note card and working with it. I promised a discount code. Here it is, Riot-15. If you use that code on our shop, you can take 15% off a starter kit. So again, $100 kit, 85 bucks with this if you want to build either of the two projects. So that's everything you need to build either a standalone tracker or one with a host, like my kit tracker. You can build it with a starter kit. And then finally, if you have any questions, so you can drop them in chat right now so we can take a look at them. But if you have any questions after this is over, or if you're watching this through the recording and you have any questions, discuss.blues.io is the best place to go for that. And that is all I had. I'm going to switch over to looking at our chat to see if anything came up there. Scott asked, any chance of using LoRa in the future? So we do have a LoRa-based product called Sparrow that you can find on blues.dev if you look around for that. We're not using LoRa for asset tracking, though, just because that requires kind of a local network. And asset tracking, you kind of have to have something that's available just more globally or has better coverage. Any other questions?
TJ, I see one question. Are you all available to do like meetings with individuals or you know, for like consulting, that sort of thing?
We don't do consulting, but you're welcome to reach out and we can chat, right? You can either reach out through the forum or on tvantol@blues.com email. Feel free to shoot me an email, reach out on Twitter, social media, LinkedIn, and we can definitely chat.
Awesome.
The other question, how long will you support for us for doing a project? So the note card offers 10 years of service out of the box.
Cool. Well, if we don't have any more questions, thanks again for a wonderful presentation, TJ. As a reminder, Riot hosts our Lunch and Learns weekly on Wednesdays at 1 p.m. Eastern Time. You can find a list of our Lunch and Learns on Meetup where you registered for the event. This event was recorded and will be posted to Riot's YouTube channel and the Meetup pages where you registered for the event. Thank you all for joining us today. I hope everyone has a great rest of the day.
Thanks, everybody.
Bye.